Good morning, all, and hello everyone. Welcome back to my channel, Ali Sir Chemistry Class for All. Today, I am going to discuss some problem related to organic acid base. To begin this problem, first I want to clear your concept. How can you explain the concept of acid base and relative acidity and basicity of the organic compounds? There are some few important point that you have to remember, and you have to know the details about the few related topics, few related points. So first one is the acid base is depend on the stability of the conjugate base. Acid stability of the acid is depend on the stability of the conjugate base, and stability of the base is depend on the stability of the conjugate acids. So number one point is stability stability of the conjugate acids or base. You have to know about the relative stability of the conjugate acids or conjugate base to explain the proper behavior of the relative acidity of the acid and bases. So this is the main key point for explaining the organic acid base, relative acidity, basicity, and so far and so on. So first point is that you have to know the conjugate base of the organic acids. What is the conjugate base of the organic acid? So if you eliminate one proton from a organic acids or any other acid, that will be the conjugate base of the corresponding organic acid. So higher the stability of the conjugate base and higher is the acidity. This is the main point for explaining the relative acidity of the organic acids. So let us start with some examples. So whatever I say, higher the stability, higher the stability of the conjugate higher the stability higher the stability of the conjugate base, higher is the acidity. Higher the stability of the conjugate base, higher is the acidity. How can you explain these observations? So this is a very simple point, and you can remember easily by considering the chemical equilibrium. If you know the chemical equilibrium, then you can easily explain. So higher the stability of the conjugate base, higher is the acidity. So let us take acids. Say an acid has a chemical formula, general chemical formula. So this is the acid Ha, which will eliminate one proton to form the conjugate acids. Which will eliminate one proton to form the conjugate base, which will be A minus, A negative. So A negative means this is an anion. A negative means this is an anion. So anions are stabilized through the minus I effect, minus resonance effect, electronegativity, vacant orbital conjugations, anything. So higher the stability of the A minus, that means higher the stability of the conjugate base, higher is the acidity. That implies that if you consider this equilibrium, you see H plus and A minus are in the product side and H is in the reactant side. If you consider this is reactant and this is product. So if you apply the Lassiter principle, you see if the stability of the conjugate base A minus is increases, so the equilibrium will be shifted towards the right side. That means the concentration of H plus will increases if the stability of the A minus will increases. That means the acidity of the corresponding compounds will increases. So this is the main point to explain the relative acidity of the conjugate, relative stability of the organic acids or any acids. So higher the stability of the conjugate base, higher is the acidity. Now let us take some examples and try to explain their relative acidity and acidity. And after this, will explain the relative basicity of some selected compounds. So now I am taking some examples. Say very simple examples. All of you know these examples. Say compare. Number one question is compare the acidity between parafluorophenol and parafluorophenol. So the question is, how can you explain the relative acidity of parachlorophenol and parafluorophenol? Let's try to explain it. So the structure of the compounds is very simple. All of you know the phenolic OH compound. Phenolic OH group. This is the phenolic OH group. Phenolic OH, and parafluorophenol means in para position there is a chloro compound. There is a chlorine, and in parafluorophenol at para position there will be fluorine atoms. So if you see here, the change is at the para position with respect to phenolic OH. Here is chlorine and here is fluorine. So the conjugate base of each of the compounds, parachlorophenol and parafluorophenol, are phenoxide ion, and this is also phenoxide ion, the O minus, and here will be O minus. So I am writing the conjugate base for both the compounds. Conjugate base means we have to eliminate one acidic proton, so this will be O minus, and this will here will be Cl, and here also this is O minus, and at para position fluorine. So how can you explain these observations? So if you see, both are anions, that is the conjugate bases. So higher the stability of the conjugate bases, higher is the acidity. Now if we can see easily that this O minus will stabilize through resonance with the participations of the benzene nucleus. So this is applicable for both these conjugate bases, but the change will occur in para position. There is a fluoro compound, there is a chlorine, and in para position there is a fluoro compound. So all of you know chlorine don't have any vacant d orbital, but chlorine has vacant d orbitals. So this O minus electron, this is excess electron at O minus, will delocalize to the vacant d orbital conjugation. So this conjugate base will stabilize, will get extra stability compared to the parafluorophenol compound, parafluorophenol conjugate base, due to the vacant d orbital conjugation. So here the extra stability factor is vacant d orbital conjugations. Vacant d orbital conjugation. That means the conjugate base from parachlorophenol is more stable than that of parafluorophenol. So the acidity of the parafluorophenol will be more compared to parafluorophenol, though chlorine is more electronegative than chlorine. I think this is clear for all of you. So parafluorophenol will be more acidic compared to parafluorophenol. Now we are moving to some another interesting examples. So let us try to explain the relative acidity of few some more example of more compounds. So let us try to explain. Now I am erasing this. I am taking some simple examples. So question number 2 is question number 2. Compare the relative acidity between hydrocarbons hydrocarbons. Compare the relative acidity between the hydrocarbons. So all of you know the hydrocarbons means alkane, alkene and alkynes. One is saturated and another two is unsaturated. So I am taking three examples. So in case of alkane we are taking ethane. This is alkane. And in case of unsaturated hydrocarbon we are taking ethylene and acetylene. So we have to consider we have to determine the relative acidity of these three compounds. This is alkane, alkene and alkyne. So all of you know there is a change in hybridization. So first we have to see where is the change occur between the given compounds. So if you identify that point, that point, then it will be very much easier for you to explain the relative behavior of acidity and basicity. So here you see the conjugate base of ethane is CH3 CH2 minus. So here the electron is in sp3 hybrid orbital. This electron is in sp3 hybrid orbitals. So this is clear for all of you. And here the hybridization is sp2, and the electron in conjugate base will also present in sp2 hybrid orbital. This is CH2 double bond CH minus. And for alkyne, the electron will be present in sp hybrid orbitals. So if you look at the three compounds in alkane, the electron pair of the conjugate base will present in sp3 hybrid orbitals, but in case of alkane this is present in sp2 hybrid orbitals, and in case of alkyne this is present in sp hybrid orbitals. So when you move from sp3 to sp2 to when you move from sp3 to sp2 to sp, the percentage of S character will increases. All of you know, with increasing percentage of S character, the electronegativity of that orbital will increases. That means the negative charge of that center will be stabilized as that center due to the electronegativity of the corresponding orbitals. So higher the stability of the conjugate base, we know higher is the acidity. So sp electron, this is that is the hydrogen in alkyne, that is terminal alkyne, will be more acidic compared to ethylene and compared to ethane. So percentage of base character will determine the acidity of the corresponding alkanes. So the order will be sp, that means sp hydrogen will be more acidic, and then sp2, and then sp3. So this can be explained by considering the hybridization of the corresponding carbon atoms, that is alkane, alkene and alkyne, So higher the stability of the conjugate base, higher the stability. Here the stability of the conjugate base is determined by the percentage of S character. That means the variations of hybridization is here the key factor. So I think all of you understand it. So the acidity order will be alkyne, and after that alkane and alkyne, alkene and alkene. Now I am going to the third questions. Today I am take some few questions of different portions of acid bases, and let us try to explain this so it will be easier for you to explain any types of questions. Again, I am taking some one more interesting examples. Let us compare the relative acidity of alcohol, phenol and carboxylic acid. So here the question is compare the relative acidity of alcohol, phenol and carboxylic acids. So alcohol, phenol, carboxylic acid, we are taking some general examples. So alcohol, we are taking the aliphatic alcohol, ROH. The simple alcohols, phenols, we are taking this phenolic OH group, that is phenol, and carboxylic acid, we are taking the simple carboxylic acid where the R's or the COH group is present. COOH. So very simple. So we have to consider about the stability of the corresponding conjugate base. Higher the stability of the conjugate base, higher is the acidity. So the conjugate base from alcohol will be RO minus, and conjugate base from phenol will be phenoxide ion. Conjugate base from phenol will be phenoxide ion, and conjugate base from carboxylic acid will be carboxylate anion. So we have to consider the stability of these three conjugate base, and if we conclude their stability, then it will be very much easier for us to explain the relative order of acidity between phenol and between alcohol, phenol and carboxylic acid. So if you see the conjugate base of alcohol, which is called alkoxide ion is very much unstable due to the plus I effect of this alkyl group. So there is no extra stability factor. Consider we are taking only simple examples. Say this is ethanol, this is phenol, and this is acetic acid. In phenoxide ion, this O or negative charge is stabilized by the conjugations with the aromatic nucleus. So phenoxide ion is more stable than that of alkoxide ion. And if you consider the carboxylate anion, so it will be stabilized through resonance. This is also stabilized through resonance, but here the stability factor is depend on the structure of the two canonical form, which is equivalent. So all of you know, if a canonical form exists in another canonical form and they are equivalent, so their stability will be maximum. So their stability will be much more compared to the other anions. So the stability of the conjugate base from the given compounds will be higher in the case of carboxylic acid, because this carboxylate anion are stabilized through resonance. Not only stabilized through resonance, but also the two canonical forms are equivalent. You see, these two are equivalent canonical forms, so their stability will be maximum. And then hydroxide ion is stabilized through resonance, and after this alkoxide ion, there is no extra stability rather than there is no extra stability. In case of some few special compounds, there may be some stability factor, but for normal alcohol, the alkoxide ion is not stable. There is no stability factor. So, if you considering the stability of the conjugate bases, so conjugate bases from carboxylic acid will be more stable, and after that hydroxide ion, and lastly alcohol. So, the relative order of acid will be carboxylic acid will be the most acidic among these three compounds, and then phenol, and lastly alcohol. I think it is clear for all of you. Now we are moving to moving some interesting examples also. Let us try to explain another few examples. Now we are taking the one more interesting examples, that is the relative acidity of the amides. One is cyclic amide and another is acyclic amide. So number 4 question is compare the relative acidity of the cyclic and acyclic amide. Cyclic and acyclic amide. So we are taking two examples. One is cyclic amide and another is acyclic amide. So I am taking the simplest amide is acetamide CH3, C double bonded O, NH2. This is the most simple amide, acetamide, the amide of acetic acids. Amide. This is the acyclic amide, and we are taking a cyclic amide. A very important compound. This is called succinamide. The amide of succinic acid. This is a cyclic amide, succinamide. So again, the factor and the stability of the conjugate base will come in operations. So the conjugate base of these compounds will be CH3, C double bonded O. So here the acidic proton will be NH proton, NH minus. So it will be stabilized through the conjugation with the carbonyl group. So all of you know this. So here the one canonical form is from. This is the one canonical form. This is two canonical forms is from. Two canonical forms means I am to say this is CH3, C, O minus, and double bond NH. But if you see the conjugate base from succinamide, what will happen here? Just to remove this proton, I am just removing this proton and putting negative charge here. So you see, this is the doubly activated proton. It will stabilize through the conjugation in the both side, in this side, and it can also be stabilized through the participations with this carbonyl group. So there are three canonical forms including this. So if you consider the number of canonical forms between cyclic and acyclic amide, cyclic amide has more number of canonical forms, and this NH proton is doubly activated by the minus I effect of two carbonyl group. So the acidity of the cyclic amide will be more compared to acyclic amide. So cyclic amide will be more acidic compared to acyclic amide. I think this is clear to all of you. So I have taken the cyclic amide as the succinamide. Succinamide is more stable than that of acetamide. Okay. Now I am moving to the last question of today's class. Question number 5. Compare the relative basicity of the given compound. So the compounds are the cyclic amide type compound. So this is a cyclic amide, double bond O, and here is one methyl group. So this compound is basic due to the presence of this lone pair of electron. So higher is the electron density, higher is the basicity. So here you can explain the basicity of these two compounds, the given two compounds, by considering the availability of lone pair of electron on the nitrogen atom. Okay, so here this nitrogen atom also present a lone pair of electron. This is also present a lone pair of electrons. But but you consider the two compounds. What is the difference in the two compounds? This position is bridged position. You see, this is the bridged position, and this is the normal tertiary nitrogen atom. So here the lone pair of electron is easily comes here and form a canonical form with the carbonyl group. So the lone pair of electron density as the nitrogen atom will be reduces. But in case of the compound, in case of the second compound, due to this bridged position, the nitrogen lone pair cannot able to participate in resonance with the corresponding carbonyl group. So the availability of lone pair in the second compound is much more compared to the first compound. So the basicity of the compound B will be the basicity of the second compound, that is the bridged nitrogen atom, will be more compared to the previous one. So here we explain the relative basicity of the corresponding compound by considering the availability of lone pair on nitrogen atom. So higher the availability of lone pair, that means higher the electron density on the nitrogen atom, higher is the basicity. So let us try to follow these questions, and I have done only 5 questions today. In the next class, I will try to make some more questions. So till then, take care of yourselves and study well and do well in examination. Best of luck for your upcoming examination. Thank you all. If you like my channel, please share, subscribe, and make some comments. Thank you all for your kind patience.